Hey everyone, welcome back to Technically You. Today we're diving into the world of routing protocols.
Ooh, exciting stuff.
Definitely, routing protocols are the reason the internet works so seamlessly behind the scenes.
Yeah, every time you send an email, stream a video, or browse the web, routing protocols make sure your data reaches its destination.
Exactly. We've done a deep dive into the research, so let's explore this fascinating topic together.
I'm ready. Let's go.
So let's start with the basics. What exactly are routing protocols?
Great place to start. Routing protocols are sets of rules that routers use to determine the best path for sending data across networks. Routers, by the way, are specialized devices that connect different networks together.
So is it like a GPS system for data packets?
Exactly. Imagine millions of cars or data packets traveling at once, with routes constantly changing due to traffic, accidents, and construction. Routing protocols help each car find the best path to its destination.
That sounds incredibly complex.
It is. And routers handle all of this by maintaining something called routing tables. Think of them as maps that store the best paths to different destinations. And
So every router has its own routing table?
exactly. And these tables are constantly updated as routers share information with each other, almost like a giant network of gossiping devices.
A high-tech gossip network. Got it. So there are different types of routing protocols, right?
Yep. And the choice depends on the size and complexity of the network.
Let's break it down. What's the simplest type?
Static routes. These are manually configured by network admins. It's like using an old school paper map where the route never changes unless you update it manually.
So static routes work well for small networks, like a home or small business, but not for something as dynamic as the internet.
Exactly. For larger, more complex networks, we use two main types: distance vector routing protocols and link state routing protocols.
What's the difference between them?
Distance vector protocols determine the best path based on the number of hops or the number of networks a packet passes through. Fewer hops usually mean a shorter, faster route.
Got it. It's like taking the shortest route on a road trip. What's an example of this type?
One classic example is RIP, Routing Information Protocol. It's simple, reliable, and has been around for ages.
I've heard of RIP. Are there different versions?
Yes. RIP version 1 is the original version, and RIP version 2 is an improved version that supports features like variable length subnet masking or VLSM. Basically, it helps use IP addresses more efficiently.
Nice. What about link state protocols?
Link state protocols give routers a complete map of the network. They calculate the most efficient path using sophisticated algorithms.
So they're more efficient, especially for large networks?
Exactly. The most common one is OSPF, Open Shortest Path First. It's scalable, reliable, and widely used in large enterprises and service provider networks.
OSPF sounds like the go-to choice for big networks.
It is. And it uses something called Dijkstra's algorithm to calculate the shortest path.
That sounds complicated. Let's just trust the math, shall we?
Agreed. There's also another type called hybrid routing protocols, a mix of distance vector and link state.
Like the best of both worlds?
Exactly. A great example is EIGRP, Enhanced Interior Gateway Routing Protocol, developed by Cisco. It's fast, reliable, and perfect for high-performance networks.
Cisco strikes again. Are there any other types?
Yes, one more. Exterior Gateway Protocols, or EGP, which connect large networks, or autonomous systems, like ISPs.
And the most famous one here is BGP, right?
Right. Border Gateway Protocol is the backbone of the internet. It connects ISPs and large networks, making global communication possible.
So without BGP, there would be no internet as we know it?
Pretty much.
Wow, routing protocols are truly the unsung heroes of the internet.
Absolutely. And before we wrap up, there's one more important protocol we should mention, SHIS, EISS, or Intermediate System to Intermediate System.
Oh, right. What's ISIS all about?
IS-IS is another link state routing protocol like OSPF, but it's often used by large service providers and ISPs because of its scalability and efficiency in handling massive networks.
So it's a big player in large-scale networks?
Exactly. IS-IS is known for being highly adaptable, and it supports both IPv4 and IPv6, making it future-ready. It works by exchanging link state information between routers to maintain an accurate map of the network.
Sounds like a great choice for massive, complex networks.
It is. While OSPF is more common in enterprise networks, IS-IS excels in carrier networks due to its flexibility and simpler design.
Good to know. ISIS might not be as famous as OSPF or BGP, but it's clearly essential in certain environments.
Absolutely. Now, we've covered a broad spectrum of routing protocols, from static routes to ISIS and everything in between.
Routing protocols truly keep data flowing smoothly, efficiently, and securely across the world.
Wow, routing protocols are truly the heroes of the internet.
Absolutely. They keep data flowing smoothly, efficiently, and securely across the world.
And most people don't even realize they exist.
Yep. Next time you're streaming your favorite show or sending an email, give a little mental thank you to routing protocols.
Well said. Okay, listeners, thanks for joining us today.
See you next time, and remember to stay curious.